So this is lecture 9, and yeah, so quickly finish it. This second one. So this is the process modeling story. Process modeling. So previously we discussed about the practical or composite material manufacturing ones. It is a real stuff, real material. But before the manufacturing, we can simulate based on a model. So just to talk very the simple story as an introduction. So process modeling, of course, it is very important. If it can be used, it can be used. But fortunately, you can find some commercialized packages to simulate composite manufacturing. Okay? So I just introduce very few ones here. So this is the part size and the cycle time for the composite material structure. Means if this kind of compression molding was, maybe so without simulation, it's not so much difficult. Because without simulation, because compression molding case, within few minutes, it's a cycle time. So you can make the many trial and error to find the optimal condition for your final mass production. But if come to the some hours for manufacturing cycle time, RTM, maybe I don't think you can have much patience to conduct multiple number of trial and error. If you can find some reasonable or optimal parameter combination before starting your trial and error, in that case, you will be willing to run program. Right? So, but it's shift. Shift means half days or something like that. Or maybe I wanted to run computer model days. Of course I will. I don't want to try an error for 10 times again, 20 times again to find the optimal point. I will not. Weeks. So vacuum infusion preparation. It's usually used for large scale ones. That this is not cow, the cow size. I mean cow size, not truck size, right? So wind blade size. That means this is about 100 meters. So if it is a large scale one, usually the vacuum assistant, the manufacturing technique is suitable. In the case, at least a day to few weeks to complete one cycle. So I will not conduct the trial and error multiple times. I wanted to avoid that case if I can run the computer models. So composite manufacturing process, you got already understand what's the layup and the molding and the curing, right? And there are two different categories of commercial packages to simulate your model. So one is use general purpose programs. It is not developed, that code is not developed to simulate any spatial case. This is a general mechanical, the equations can be simulated inside. Actually, they just solve partial differential equations. And all of engineering principles can be formulated into the form of partial differential equations. That means general purpose programs for fluid flow or structural analysis, those kind of things can be used to simulate your model too. But in the case of more sophisticated engineering knowledge is needed. Because so how it can be used for your model, you must assemble all of possible fragments by yourself. That means you need some profound knowledge of it, okay, to use in order to use a general purpose. It's Abacus or StarCD or Fluent, ANSYS, those kind of things are general purpose programs. It can be used for structural analysis, failure prediction, material optimization, any kind of things can be used even for the composite material manufacturing process. So it can mold filling and the curing, demolding, because curing means it is the viscous fluid flow problem, and the heat transfer problem, and the rheology problem. So those kind of can be done. And the automated fiber placement, these kind of things also. If you want to develop these machines, you can use dynamic related commercial packages like Adams or NC's Dynamics, such like that. Right? And the compression molding also. These kind of things, all of those can be used to run your model. So this is a structural element. So can be modeled and analyzed, and computational dynamic CFD is from the Fluent or StarCD or ANSYS, the multi-scale modeling, Cosmos, optimization algorithm. So there are so many different kinds of commercial packages for general purpose. So those I think you will not want to you will not want to use. Rather than it, you want the special purpose one. If you wanted to run the composite material molding, there are some specialized purpose programs. Those are programmed specially to apply for your problem, your model. Okay? So I have no relation to this Moldex or to other software I am introducing here. I have no relation to those kind of companies. But I just wanted to show that this is not limited. So there are more softwares to be used like this. Okay? For example, this Moldex 3D, this is not so famous one. This is relatively recent one. It's a Taiwanese simulation package. So by using those kind of the special purpose program, you can pre-mold before conducting real manufacturing process. You can make your model. That model is that they provide the tool, pre-processor tool, so that you can build your own model easily based on the related terminologies you have learned so far, discussed to your point. So based on that, you can be guided guided to build your model, and you can choose many manufacturing parameters as a preset the number, so that in that case, what will be the result after molding? Okay? Then, this case, there are some defects. If you set some, this is kind of the experiment, but the virtual experiment. Experiment means if you put one the parameter set, then you will get one case output. If you change your parameter set, then you will get a different output. So you can guess, I want to use this manufacturing parameter. In the case, what will happen? Okay. In this case, put some parameter, then see, there are some defect. There's defect. So this parameter will not be good choice. Okay. You can know. It's a very cheap way, okay? Very cheap way, and a very fast way. So, so based on your chosen parameter set, you can see many different kinds of the output. It's a residual stress distribution, or it's a porosity, or crack, or on wet zone. Any kind of output can be checked from your. This is another specialized the software. This is ESI software group in France. So they're PEM Composites. So they provide PEM, RTM, and any other different type of VRTM module, RTM module, CRTM. There are many different kinds of composite molding technique can be simulated easily by this. So PEM RTM case, RTM process can be simulated by the simple guided model. So this they compare. So some of users they presented the result. Actually, this is from one of Japanese user of this PEM RTM user. After using, he compared his real the manufacturing result and prediction result. He just compared how accurate both. So very accurate. So by using PEM RTM model, this is purely the virtual production, and this is a real production result. So there are preform inside, right? And it is filling. It can be checked. Both is compared. Right? So without this kind of real molding trial, by just by constructing your own model and set your parameter, you can experience in advance what kind of output will be expected, so that you can get virtually optimal parameter sets before conducting your real molding. Okay, so you can save tremendous time, money. Okay, although you must pay for this program. Yes, it's I believe it is about $30,000 per year for use this program. Anyway, this PEM composite you can except RTM, VARI is also specially developed, and the CRTM and the HPRTM and more. You can find them. And they also provide the many different kinds of usable fiber properties and the matrix properties and its rheological properties depending on temperature. So the optimization of parameters means, for example, you need to understand terminology. You choose among the options LCM. So LCM is because you want to simulate RTM process. That means RTM is part of LCM. So that's why, although you have not a background of any mechanical engineering or industrial engineering, even in that case, you must know what is LCM as an article level. So that LCM means RTM, RIM, VARI, it's all over part of LCM. So you should choose LCM to use this program for your RTM model analysis. And the injection pressure or flow rate can be chosen. Temperature cycle you can set. And the location of injection gate you can set. And the vent vacuum port location you can set. If you set different position, you will get different output. Right? And the curing cycle also you can set. Those kind of things as an input, as you will typically you will evaluate from the output the filling status and the filling time, how long will it take, and the porosity level you can check, and the infusion time you can check, and the pressure applied to the mold you can check, and the temperature you can check. Okay, this is instantly you can get this kind of output if you set input like this. So trial and error. You on computer you can optimize your parameters. You can refine your input parameters. Then, if you have satisfactory, you have satisfied the output here, then that chosen parameter set will be tried on your real molding process. Then, presumably, maybe your optimal, real practical optimal parameter set will around that. Maybe 2 or 3 times test run will make your final manufacturing setup as a virtual optimal test, right? So this kind of specialized purpose program will give you great freedom to choose manufacturing parameters. So the prediction of fiber orientation, residual stress, defect identification, all of those can be possible from. Okay. And future trend in composite modeling is multi-physics integration will be improved. Artificial intelligence will be engaged. In that case, maybe you don't need to put your input algorithm by yourself, input parameters by yourself. It will be chosen by AI. If you want to have something, then you can just describe what kind of output you want to have, what kind of facility you have. If you let the program know, then automatically it will find the first optimal trial set. That is possible after AI is embedded with the special purpose programs. Okay? This is what is benefit if you use specialized software or even general purpose software can be used. In the case of what kind of benefit you can enjoy, I just try to introduce you. Okay? Education? So 2 lecture time is already. Yeah.
Which simulation is more important, like process modeling or structural modeling? Which one is more important for the component?
For the composite materials,
Which kind of simulation is more important, like process simulation is very
processing.
important, or structural modeling?
I think process. Process modeling is very good. And the product modeling is before manufacturing process. So in design level, maybe you have no idea about product itself. Maybe it is given to you. This kind of product I wanted to have. So just manufacture this for me, something like that. In that case, you don't need to run the structural analysis, something like that. But if you want to design product by yourself, in that case, before starting the processing simulation, you need to define the product, right? In that case, structural analysis should be used. Yeah?
So like means if I am to produce any product, firstly we should go towards the product modeling, and after product modeling, if I have finalized the product, this material will be used, then come to process simulation.
Correct.
Thank you.
Okay, thank you so much. Today, this is my 2 lectures. Okay, so I'll see you tomorrow. Thank you very much. Thank you. Oh, it's cold here.